Yeah, thank you guys. Thanks for joining. So in yesterday's class, guys, we talked about basically Spark different joins, right? Spark broadcast join, then short shuffle merge join. Plus, we also talked about adaptive query execution, Spark AQE. So basically these joins, which I explained, Spark, broadcast join, short merge join. These are the joins which help you, let's say, when you're doing joins between two different data frame, right? And broadcast join help you if your one of the data frame is big and one is small. And I explain you how small uh, data frame it transfer to all executors, right? Memory, and that's how then you join two different basically mm, data frame, right? And broadcast join and short support merge join mostly we use when you have two data frame are big enough, right? Not big enough in the sense neither of data frame can fit into the memory of another data frame, sorry, executor, right? So when you are big data frame, you cannot use a broadcast join in that case. So in that case, short support shuffle merge join that we should use. Okay, Spark by default use short support shuffle merge join whenever you do a join between two different big data frame. Okay, then we also talk about the AQE Spark adaptive query executions, wherein we talked about, let's say, the different concept, right? Whenever you do the shuffle, let me present my screen. One second, that to explain that part. So whenever we do this joins, basically, right? Sorry, AQ. I explain the purpose behind the AQE. It's adaptive query execution technique, right? Wherein, let's say, um, for example, whenever you do the shuffle join, right? Whenever you do joins between two data frame, let's say in this case, I'm joining employee data frame with the help of project data frame, right? On employee ID. The moment you do join operation, Spark internally shuffle data, right? And the moment it shuffle, by default, Spark create the 200 partition. But see, I have a very small data set in which I have just four unique key. I told you 101 to 104, only four unique key. For such cases, if Spark is creating 200 partition, that doesn't make sense for me, right? Better I should control. Of course, I can control with the help of Spark configuration, right? This configuration, but that's also not good, right? How I can know that how many joins key are there in my code? That something is never I can predict before every time, right? Because we on data engineering, you are running these things daily basis. How I can know that, okay, today upstream system is sending one, let's say 100 unique key, and tomorrow 200 unique key. There is no control, right? So manually setting these things is bad idea. So what AQE help us? AQE help us to calculate the statistic at a runtime so that it will create the number of partition according to unique key you have in your data, basically this data frame, both data frame. So in this case, since I have four unique key, what Spark did, it just create, I explain this four partition, right? And to execute this four partition, it create this four core. Why four core? Because each core would run on each partition. So that's how it will work, right? Whereas without EQ, you see, after setting this configuration, Spark SQL Shuffle partition 10, it will create 10 partition, but we need four only, and six partition will be still empty. And for the six partition, of course, Spark will create a 10 cores. So we are unnecessarily creating extra cores, right? And extra partitions. So that is extra burden on your Spark cluster. So to avoid this, AQE help us. It will create the limited resource with the limited partitions. So that I explained, right? And also we talk about the skewed join, right? If let's say when you are doing data frame joined, let's say this case. So in this case, you see that one of the data frame is big enough and one is small. And this executor, see, these three executor would start and finish on time. But what about the last one? This first one, sorry. Because this data frame is big enough, it will take more time to finish. And for each data frame, I have created, let's say we got one task. Task is nothing but the uh, core which will work on this two data frame joins. So I have only four tasks. Three tasks would get finished quicker, but one task will take time. What Spark AQV skewed join partition help us, right? In case of skewed join, how Spark AQV help us? It create an extra task for you in this case, right? And it even split your big partition into small partition like this. And it even duplicate your this employee data frame so that it can match this data frame with this one and this with this one. So that now you earlier you got the four tasks, now you got the five tasks, and with the help of this five tasks, you can complete your execution on time. So all the executors will finish their job on time. So that's how Spark AQE help us in case of if your data is queued, partition is queued, and how you should enable it. Let's say if you wanted to tell Spark that, okay, I wanted to use AQE with this queued enabled, this is the configuration you need to do. Spark SQL adaptive enable true, and then Spark SQL adaptive skewed join enable true. Apart from that, let's say whenever you are using the moment, let's say you run add this configuration in your Spark notebook. If you are joining two data frame and one is small and one is big, Spark automatically do broadcast join in that case as well. You don't need to specify I need to do broadcast join. So these are the some advanced techniques that Spark help us, and that Spark EQE help us, and that really good for data or computation perspective. Then we guys talked about crawler as well, right? Let me go to the crawler part of the PPT. And yesterday we create. Okay, let me share this. So yesterday class I explained, right? What is AWS Glue? It's basically serverless data integration service, right? Wherein there are multiple component we went through, like this data catalog, crawler, ETL job, and other things, right? These are the three main component, okay? And of course, notebook as well, right? Glue Studio and notebook as well. And job bookmarking also you can do based on your requirement. So these are some key component over here. The way guys ADF help us in, I'm talking about ADF, Microsoft Azure, right? So the way ADF, Azure Data Factory or Synapse Pipeline help us in data transformation in AWS, we have AWS Glue service. There are other services as well, EMR and EMR, for example, Elastic MapReduce, okay? But that's basically Elastic cluster to work on a big data project. But Glue got more popularity because of its low code based solution. You can just write visual with the help of some visuals, you can create a transformation and you can move data, you can create the ETL and move data from, let's say, one source to another source. So that's what the job of data engineer, right? So Glue Visual Studio is something that really good if someone wanted to go with the low code based approach, right? And then I talk the main feature of AWS Glue, that is crawler. What its purpose? It guys connect to different data sources. Okay. In this case, I just mentioned S3, but let me go to the next slide. Okay. What is the purpose of crawler? Sorry, let's say what crawler do. It connect to the S3 or any other data source. It's shipped, or for example, your data which is on-prem, right? Or let's say Amazon RDS. It can connect to any data source, and generate the metadata out of it. What that metadata is, and it support any file. Let's say in your CSV you have JSON file, CSV file, Parquet file, ORC, right? Or let's say it can connect it can connect to the S3, Redshift, JDBC sources. Let's say on-prem I have some database and there I wanted you to connect and generate the metadata, right? For that purpose you use crawler, right? Now what crawler help, right? Crawler connect to all these data sources, okay? Crawler connect to all these data sources and then it basically generate the metadata out of it, this data catalog which we talk, right? It can, the way you see there is central component crawler, it is connected to the S3, RDS, Redshift, right? Just a second, guys. Yeah, so it can connect to these different services, right? This crawler, S3, RDS, Redshift, DynamoDB, JDBC sources, and it generate the metadata out of it. Uh, So what is metadata, guys? It's nothing but it's this database, whatever you are saying, and tables that you are saying over here are the logical table. That means they are not physical. The tables, that data still existing this layer, but you can query from these logical entities or logical table that data catalog create. But guys, you see the real benefit of it in one organization, in one there can be multiple data sources, right? Organization can put their data in S3, RDS, right? Redshift, DynamoDB, on-prem sources. It can connect to any other source, right? They can keep their data anywhere. But and each data can have their own truth. Okay, some data, some data talking the different truth in JDBC, but same for same concept. Data in Redshift is talking the different truth, right? There is possible you would get the different truth of this based on the same data. What crawler help, once you have data at a single place, you can get the single source of truth. Because you are now have the complete control over all these data set, and you can query it so that you can generate a single source of truth. How you will query? With the help of Athena or Redshift. There are multiple options are here. So that's how, guys, main thing about data catalog. We talked about this yesterday, right? And you can also query this with the Athena and Redshift. Now, guys, and then finally we also went to the AWS Glue ETL, right? I told, okay, data catalog we created with the help of crawler. We connected to the sources, let's say S3 or any other source we can create, right? So once we connect it, we create data catalog. Now on the data catalog, we need to do some transformation. With the help of AWS Glue ETL, you can do the transformation. You can do extract, transform, load, right? To if you wanted to use code-based solution, it support Spark and Scala. It also support a visual base that you can do some drag and drop sort of operation and generate the ETL pipeline. Okay, all things, right? Basically, filter aggregation and other things, that sort of transformation you can do with the help of their visuals that they provide. I even showed you yesterday that all these visuals, right? And then you can load to different. You can connect to different source, do some transformation either via visuals. That is means whatever the, if you go to their console, you see the join and other things, right? I will show in some time now. And then that is one option. Either you go to visual base or you apply the code based solution. Do the transformation, sorry, do the transformation and load data into the target. So that's what the purpose of Glue ETL, guys, right? So what we did yesterday, let me go to the, we create one end-to-end solution yesterday. See, in real world, you might have some, of course, you will have the complex solution, but since we are learning, I just try to keep things simple. Okay. I have created two buckets yesterday, customer and sales, and I uploaded data into this raw bucket, right? Let's say in S3 bucket. Imagine that currently I uploaded the file, but in actual project, you will be having some upstream system. We call that as the upstream system, which push data into your S3 bucket. That upstream system, imagine, is sending data in every 1 hour. Okay. Now with the help of AWS Glue, what we did, we create the catalog out of it. Okay. Now that catalog, I showed you how to query with the help of Athena. And then with the help of, on the same catalog, with the help of AWS Glue ETL visuals, right? I just some drop duplicate, because I told you that in this yesterday, there is some duplicate data in these two files. I drop this duplicate and create the enriched layer. See, in enriched layer, we'll be having clean data. What is the meaning of enriched layer, guys? It will have some clean data. Of course, if you wanted to do some analysis, you wanted to do analysis on clean data, right? So for my case, I just, for this simple transformation, I just apply one transformation. But imagine, guys, when you are working on some big project, you will apply a couple of more advanced, all this transformation, right? Drop duplicate, remove NA, right? Or let's say you don't want, let's say, some country specific data, anything that can be business use case based on your requirement, and you can move this data into the enriched layer. Once you got data into the enriched layer, then with the help of AWS Glue ETL, again, you can, what we did, once we data got moved to the enriched layer, then again, we apply some transformation on a data which is in enriched layer and move that data into the business layer. That's how, guys, typically in project you will see operations. Data people move from raw to enriched to business layer with the help of some transformation at each layer. Here we apply some transformation, right? Here we apply some transformation, and here also we apply some transformation. So that's how, guys, data will get moved from this entire layers. Now let me show you AWS console. Yesterday, you remember we load data into the business layer, right? And let me take you to that business layer data set. So as you see my this screen, okay, as you see my AWS console, right? This is a business layer wherein we load data after some doing all transformation and all, right? Now, guys, I wanted to, let's say, see this, because this data, what's in this data set, right? There are multiple way. Earlier, AWS support S3 select, but now they downgrade that service, right? There is also one more good way to create the metadata out of business layer. Okay, so we basically data catalog out of business layer. So we'll see, once we, let's say, move data into the business layer, how to query that data. So for that, what I will do, I will go to the catalog. Okay, this I am going to the AWS Glue. You just go on AWS console, search for AWS Glue. Okay, go to ETL jobs. Okay, in ETL jobs, see, you currently, so let's say, since we wanted to create a table, right, out of data which is in enriched layer, that is business layer. So what I will do, I will click on a crawler, because I wanted to crawl that data and generate the catalog out of it. So how to do that, right? Let hit on create crawler. I am giving the name as a business layer. Okay, for this crawler name, let me business. Let me give this business, or let me business crawler. Okay, so let me, it's just a name, and let me add the data source. So where my data is, guys, my data is in business layer, right? And I, yeah, I think it's direct in business layer, not any specific folder. So I click on a business layer, click choose. Okay, now, guys, because this ETL is not one-time activity, every time you are getting new data into the, let's say, your this layer, business layer, right? So there are multiple things that you can do. Either you can, if let's say you wanted to crawl all subfolder, okay, all the data that you are having in S3, you wanted to crawl and generate the metadata out of it. That one option you have, right? This option you will use the only, let's say for first time. Let's say you're running your job on a very first time, but on a subsequent run, you don't need to scan entire earlier scan data set. You will be using only this option to scan new data set only, right? So suppose at a 9 p.m. I run, 8 p.m. I run job, I showed you on demand how to run that, right? Now also we will do, let's say 8 p.m. we run job and we got some data into the business layer. Now again, let's say 9 p.m. we run job. We don't want it to scan the data which got earliest already scan at 8 p.m. right? We want only 9 data which got the 9 p.m. at a 9 p.m. scan, right? So for that, maybe we should use these options, right? Now let me go to the add S3 data source. Okay, other options maybe we can ignore, not necessary for us. Okay, let's create IAM role, because guys, this crawler need access to your S3 bucket. I'm just creating this business role. This IAM role got created. Now this IAM role, with the help of this IAM role, this this crawler having access to your bucket, which is business layer bucket, right? This bucket basically. Without this role, your crawler cannot access that bucket. Now let me click on next. Okay. It's asking me to create database. Okay. Let me click on add database and let me click on business. Now guys, in this case, I'm just creating only one. We need to give it in lowercase there. In this case, I'm just creating, let's say first, let me create this database. See, I just create this database, right? And in this case, I'm just loading one table into that database, that one table from my S3 bucket. So basically whatever you are seeing in my S3 bucket, right? Sorry, here, right? I'm just loading this particular data in the form of table, whatever the snappy parquet file you are seeing, right? This table, sorry, these files I am loading into this database in the form of table so that I can query. Because see, when I'm moving data this across the layer and I wanted to see business layer, right? I wanted to generate some visualizations out of that, to do some, to I can see create some chart and all, right? How that data look, right? So for that, I need to be having some data in queryable state, right? So for that purpose, we are doing this activity. Okay. So I create database, right? Table name, I'm not interested in giving any prefix or any option. Okay. Let go next. So you see scroller schedule. There are multiple schedule you see, on demand, hourly, sorry, on demand, hourly, weekly, monthly, right? And custom cron expression, right? Guys, imagine I started this stage. This is what I was explaining, right? I started staging at 8 p.m. and this entire data got from the source. I get data, remove duplicate, right? Sorry, apply some transformation and all, right? Uh, so at 8 p.m., let's say I got this data, right? I drop duplicate, then I move data into the English layer, and then finally I move data after doing some transformation. I move data into the business layer at 8 p.m. But now let's say when job would run at a 9 p.m., right? I don't want it to use the same data set. I wanted to use new data set. For that purpose, I told you that we should select that particular option, right? Now, currently, I am not running it on hourly basis. We just need to run just for the sample purpose. So let me run on demand and let me click on next. Create crawler. Okay. Now crawler got created, guys. Now you need to run this crawler. Let me run it. It started. You see it's in running state. By the way, yesterday we applied what are the filter that we applied, right? Here we applied a filter of, so when let me show this diagram. Whenever we applied some transformation in this layer, we apply only the filter like, so after dropping data, we apply filter like, I just need the data with some, I believe more than 100. Let's say if product price is more than 100, I just need that data to be persist in business layer. I don't want, I am not caring about the product which is having value less than 100. So this is very simple transformation I'm doing, but in your real project, there would be multiple transformation which I explain you, right? In our Spark hands-on session, the coding session, right? There can be multiple transformation you can apply on top of data and all. But just for this example, I just apply simple transformation that, okay, I just need the product with the uh, amount greater than 100 and load the data into the business layer. Now, let me see if my crawler got completed. Okay, it show it succeeded, completed. Now guys, if it complete, it should create the table. Let me refresh these things. You see, I got one table over here. Now, let me click on view data. So the moment you click on view data, it will take you to the Athena page. And of course, you will be getting charged for that. Athena is a tool which will help you to query data on S3 buckets. And you can do our normal the normal SQL that whatever you do, right, in day-to-day activity. All this data querying part you can do on Athena with the help of Athena on a data which is available in S3 bucket, right? So you see, I just got the 7th row. I just got the 7th row, and you see here all the amounts are greater than 100. And of course, in this data set, I don't have basically, uh, if you see, I don't have any duplicate over here in this data set. So if you see in earlier case, if I show you my data set, again, this was very simple example I just gave. If I make some example complex and with this new thing, right, it may be maybe sometime not people would be able to understand. So let me show you these things. But yeah, transformation we can do complex, and in actual project we will do some complex transformation, right? But just for example, I just make it simple. So you see in my customer CSV which I uploaded, right? You see the duplicates over here, right? But whereas in final output, I don't see any duplicate. In a sales also, I have some duplicate over here, but in my final things, I don't have any duplicates. So what is the reason behind that, guys? Because in my so first to understand two things, duplicates are there, and then I apply transformation that, okay, I need only data of sales, okay, having amount is greater than some number, okay, let's say 100 in this case. You see there are some number which are less than 100, right? For example, this one, right? So I don't want to do analysis on the those product which is having less value. So if you now, if I again now go to my this screen, you see all right data I got only unique data, no duplicates over here. Why I not got duplicate? Because when I move data from raw layer to enriched layer, I drop duplicate in yesterday call, right? Whatever I showed you. And then at enriched layer, I create another ETL to get only the product with more value greater than 100. So this is how, guys, end-to-end transformation we did yesterday. And now we can query. Now, guys, how generally happen on this in industry on this business layer, people use some other visualization tool, like let's say, because, sorry, let me just see. Slide. Okay, QuickSight is another AWS tool, guys. visualization is not in our scope because that more the visualization team would do. But what they do, they connect to this your business layer and do some visualization like bar chart and pie chart and the way people wanted to see and visualize data. So that's the purpose of visualization tool, right? This is a quick site tool just for you to let know, right, how things happen in industry. Okay. So this is how guys end-to-end things happen. Now, guys, we cover this entire thing with the help of visualization tool, right? Glue visualization tool. But I told you Spark also support a code-based solution. If you wanted to uh, uh, write the same thing with the help of some code, right? Then how we should do, right? So now let's do the same things in for the in a code-based way. So let me again go to the this. I'm on AWS Glue. Okay. On AWS, AWS Glue, let me go start from the first page. Okay. The moment you search AWS Glue, you need to go to ETL jobs. Okay. Okay. Now, guys, let's create. Earlier we create the visual ETL. Now let's create the notebook. Okay. Let me click on notebook. Sorry. Let me click. Okay. Start fresh because I wanted to create the new notebook in this case. Okay. It's saying a role. I will create the, see guys, what role we need to create? I need AWS Glue to having full access. In this case, I create one role, Glue admin test. What is the purpose of this role? I just went to the IAM console yesterday. It's the same role that we created in yesterday's session, right? I went to the IAM console. I create the new role, right? With Glue having administrator access. So that role only I'm using, guys. For this session, maybe I will not create the same role again, new role. So we can use the same role. So this glue service now having admin access. So in actual world, actual reality, you should not use admin role. Basically, it's always preferred to give only role which are the specific, right? But just for this demo purpose, I apply the admin role. Now it would show you that, okay, notebook, it will take some time to create this notebook. Okay. This is Jupyter symbol, guys. Whatever you see, just right. It's a Jupyter notebook, just for you to let know. So, guys, you are now on Glue Studio notebook, right? And it by default give you some code. Just let ignore for now. So let's, okay. We are now into the Jupyter basically this notebook. Let me just give them some name. I'm just giving its name analysis notebook. Fine. Now let me do few things, guys. Let me go to the AWS S3 first. What I want to upload, just show you from the scratch. Otherwise, maybe if I work on earlier data set, something might be not clear to you. Raw layer, right? So raw layer, right? This is the data set we created yesterday, guys, customers and sales. So let me first of all delete this two data set. Oh, Let me just create empty bucket from here first. Let me unselect these things and let me go here. Can I do the same? Okay, I think it is asking me to delete once. Let me click on delete. Here is delete object, and then yeah, sorry, permanently delete. I wanted to delete this whatever data that already I have created. Okay, and sales as well. Delete. Earlier I deleted customer folder as well, but that customer folder I need by mistake I have deleted that. But anyway, let me get that new customers folder. So customers is a new folder, guys. Okay, let me, yeah. So this is the customer folder I have created, right? And let me click on a create bucket. Now guys, I have two folders in a raw layer, right? And now we will do the same things with the help of AWS, sorry, AWS Glue Notebook, not Visual Space things, right? Let me upload the files into the customer folder, customers.csv. Click on upload, add files. Okay, I uploaded these files over here. And let me do the same for sales as well. So guys, currently I'm just uploading manually, but you imagine that in your actual project, there will be some upstream system which will be pushing this data. Okay, so I upload both the things. So imagine guys, now we got data into the S3 bucket. But Glue cannot only connect to S3, it can connect to the DynamoDB, RDS, anywhere, right? So just for demo purpose, I showed you that you can connect to any places and generate the data catalog. In our use case, we just connected to in our use case, we just connected to Amazon S3, right? But Glue catalog can connect to DynamoDB, RDS, and can generate the centralized catalog. And on that catalog, then you can apply the ETL, right? But for this demo, I am just connecting to the S3 and created it to this bucket, right? And now we'll be creating the catalog based on top of that, right? So now let me go to the S3. Okay, sorry. Where it is, not, yeah. So here we uploaded two files, right? Now in customer also I have one file, and sales also I have one file. Fine. Now guys, first of all, the way I told you, right? Even if you go for this approach, first of all, you need to create the catalog. I have deleted the catalog that I got yesterday just to save some cost. So today, since I uploaded these files, with the help of AWS Glue, I will create a new data catalog. Catalog, I told you, is a central logical database with the tables, wherein your source is in underlying data sources, but you can query it from here. So let now create the data catalog. So let me click on uh, notebook. Okay, let me do one thing. Let me click on a Glue here. Okay, and I can go to, let's say, go ETL. In the same view, I can see the data catalog, another option as well. Okay, Let me just move these things for you. Yeah. So guys, since we need to create the catalog, what I will do, I will crawl my raw layer. What is my glue is doing now? My AWS glue will crawl that S3 raw layer. Okay. S3. This is the name I am giving for my crawler. Next, let me select the data source, right? In this case, I am selecting my raw layer, right? And here, let's say I am trying to connect to the customer. Okay. So customer I selected. Then let's say since I'm doing this first time, I will use crawl or folder or subfolder. But if you are doing, let's say a subsequent time, you can choose the next one. Okay. Now let me click on a create one, create ST color. Let me go to the next. Let me get the IAM role. Let's say customer. Right? Because our glue need access to S3 bucket. So that's why I create this IAM role. I'm moving to the next. See, earlier I have database is business layer, but now this data is in raw layer, right? So I will create another database over here. And this is the same thing that we created guys yesterday, but now with the help of notebook. Raw. This is our, yes, let's say raw layer DB, for example. Okay, this is my raw layer database. So this is the database I have created. Let me go here. Let me refresh. Let me select my raw layer database. Okay, I don't want it to give any specific name, and I wanted to run it's on demand basis. I will click on a next. Okay, and now let me create a crawler. Let me run it. Okay, it will start run. Let it get finished. Okay, see, we can, let's say in your one folder, let's say bucket, you have multiple folder, you can scan all the things, but just for simplicity, I'm explaining you one by one. Uh, so meanwhile, it will run. Let's do one thing. We can create another crawler and we can see both the crawler at the same time because it will again take some time to run and all. Or let's do one thing. Let it get finished. Why it gave this message? Just wait. I think it's prompt me to restart sign in. Just let me sign in, guys. I don't know. Suddenly it popped up that message. Just a second. Yeah. Sorry, guys. I think that automatically popped up some message for me. Okay, now I think my crawler got completed. Let me reshare my screen. Okay. See, guys, my crawler got completed, right? And I can even see this So this is my crawler S3 raw layer, right? And this crawler got completed. Now I should see some table. If I go to table, I can see business layer elite as a sorry, a customer is a because since we scan on this data set, you see the customer as a data set we got created. Now guys, you can use the same crawler to crawl another data set, or you can create a new crawler. For our case, let's do one thing. I will create another crawler. Okay, let me show you one example. Earlier, see, I just selected to one table and create one. Sorry, I create one crawler and connect it to the one table. But let's say I have one S3 bucket, right? And in there I have multiple folder. Can I create the multiple tables for each folder? Let's see that. So if I do that, if I wanted to explain that part, let me click on add sources. Let me click on S3 bucket. Yes. AWS raw their elite, right? That's what our bucket name. I click on the next. Okay. Crawl all subfolder. Okay. It have two folder, customer and sales. Add to S3 bucket database. Okay. Now let me click on next. Let me click on role. Let's say I need to, since crawl all the dataset, I just creating the role with the all. Okay. And let me click on next. What I will do, guys, just to not make, because earlier we create only one crawler for one database. I will create now in this case another database just to show you how to scan the multiple folders and create the bucket out of it. So, sorry, create a table out of it. All just I give name all raw layer tables over here, right? I just created table. Now I want, guys, in this all raw layer tables, I should have both tables to get created. Okay, fine. I don't want it to give any enable table prefix or anything. We'll run it on demand, and let me give one create a crawler. Let me run on a crawler. Now, once this crawler get completed, guys, I should see two table in my database. Let it get finished. It's not idle, right? For each, go to the S3 bucket and specific folder and create a crawler. In your S3 bucket, let's say, in this case, I have the elite, the folder that I give, right? Let me, now it should not ask me the pop-up. Okay. So in S3 elite layer, I have two folder, right? Customer and sales. So it's not idle that for each thing I will be creating the crawler. It can have the 100 folder. I will just crawl one time, and for each one, I should see some tables created in my database. Let's see if that work. Okay, it show it completed. Let me go to the database. This is my database is, guys, right? And let me click on this database. You see, I got a two table over here, right? Customer and sales. Now, guys, what we will do on this customer and sales data with the help of notebook, we do some transformation. Okay. Now, let me go to my notebook. Where's my notebook? Okay, let me sign in. Since once I got that popped up, and now in every tab it will ask me to sign in, but it will not take authentication now. Since I already authenticated in one of the tab. So I am now in AWS Glue notebook section. Let me sign in another tab as well. Okay. So this notebook, this is Jupyter notebook, guys, and let this notebook come. Okay. Just giving some sample. Okay. Now, guys, this is a Glue Studio notebook, right? It come up with some auto pop-up code. It's nothing but our the way we work on a Spark, right? These are because we are running the things on AWS Glue. There are some by default Glue library. 1 second. Yeah. So see guys, when because we are running the code on AWS Glue, right? It by default imports some library. So just maybe let it be as it is, and then it create a Spark session. So what it's doing, it create a Spark session. It's nothing but whatever we earlier did in our IDE, PyCharm IDE, and it convert that Spark session into the Glue context. Because here the way it works, it directly doesn't work with the Spark session. It convert the Spark session into the Glue, and then out of Glue context, it create the new Spark session, and then it would work with this Glue session. So if you see earlier, we will be using Spark and then just create data frame, right? So in this case, you you will not be using direct Spark session, you will be using Glue context. That's what we are seeing over here, right? It's create a Glue context, whereas we will earlier what we were doing Spark dot create data frame, right? So there are different in term of method, but underlying things are the same. It just it create a it need a Glue context, but how it will create a Glue context based on a Spark context. So Spark, you of course you need to know. So the way Glue work, it first of all get Spark session and then get the Glue context out of it, right? And then you from that, let's say once you got this Glue context, you can connect to your data catalog, right? So let me show you. Let's say you got a Glue context from your Spark session, right? And then this is the whatever session you see over here. It's a Glue context dot Spark session. So now let's go to the next things. Let me just run it. Okay, it run. Right now, guys, let me show you some piece of code quickly. If I will type manually, then it will take more time. So that's why I just quickly, and I will explain you line by line. Don't worry about it. Create data frame. So what we are doing, guys, over here, we are just creating data frame from our basically. So in this case, our table name and customer name, sorry, table name is customer and sales, but our database name is different, right? What is the name of database I have you? Let me go there. This is the database name I give, right? Let me copy this database name. Let me go to the AWS group notebook, right? I just paste that database name, right? So what I'm doing, I'm using Glue context, create data frame from catalog. From where I'm creating data frame? From that data catalog, right? What is the database name of that data catalog? It's a this is database name, and what is the table name? Customer. So you will get the two data frame, customer and sales. You can print the schema. Then guys, once this is see, this is DYF, right? It's associated with the Glue context. What we are doing over here, this DYF.sales plus this DYF.customer, we are converting into the our Spark data frame. And then here onward, we will work on Spark data frame. So that's the only thing. It's different. So in a Glue, whenever you are getting data frame, it having a Glue context, you are converting it to the Spark context with the help of 2DF and 2DF, right? And then now you can work on these things. So let me run these things now, guys. So the asterisk symbol you are seeing over here, that show that program is in running state. If it pass, then we will see the result. Otherwise, let's see how things happen. You see, it print the schema. It first print schema for customer and then sales, and then it even show data from sales and customer, right? Sales data you got and customer data also you got. Now guys, once you get that data, what next thing we wanted to do? Let me just take that things. I will explain line by line. Now guys, see, we got data frame, right? What we are doing from a sales, we got sales DF, right? Sales DF and customer DF. Now on a sales data frame and customer data frame, I am dropping duplicate based on a customer ID. Okay. So on a sales, let's do one thing. On a sales, maybe we can drop based on sales ID, not a customer ID in this case. Okay. Drop duplicate on a sales data frame. If there are multiple duplicate sales ID, I wanted to drop them. So let me drop with the help of sales ID, and in a customer, let me drop duplicate data frame with the help of customer ID, right? These are the method we talk in detail in our Spark hands-on session. We talked about these things. So we got now unique data frame. What I'm doing now, I'm joining this customer unique data frame join with sales unique data frame based on a customer ID, and I'm filtering the column. Basically, I'm filtering the amount column having greater than 100 and output dot show. Let me run it, guys. You see, we got the record. It's the same record, right? The same set of data that we got, we see it in this business layer, right? So we got the same data that, okay, all the amount is having greater than 100. Now, guys, if I wanted to load this data into any one of the bucket, what I should do? Let's see how we should do these things. So to load into S3 bucket, let me show you one of the example. Okay, to S3, S3, right? How we should write? See, guys, I got one output, right? Now understand these things. The way I told you, right? In Glue, you cannot write direct Spark data frame. First of all, you will get a Glue context. From Glue context, you need to create your own Spark data frame. And after you, and then you will do all the transformation that you wanted to do over here, right? Whatever I have explained in earlier sessions, right? Your code can be literally 100 lines of code over here. Once you got your final data frame, that final data frame you need to convert into the Glue context again. So you see the output that I showed over here, right? This output, right? And from this output, I am creating the data frame which Glue recognize. With the help of dynamic frame.df method, I am passing my output, which is my Spark data frame, and then Glue context, whatever I have created earlier, right? This is I have provided. This is just a name that I have created, and this can be anything. It's just a naming convention. I can write my name over here, not an issue. But what is the things over here? What I am passing output, Glue context, and then with the help of dynamic frame.df, I am creating the data frame which Glue recognize. And now, guys, to write data to the catalog, right? Let's say write S3 with the catalog update. What, because see the data frame I wanted to write to the S3 bucket. How I should do? Right? The Glue context, the same Glue context, get sync. First of all, I need to get the path where I wanted to upload data. So guys, let me do one thing. Let me create the new path for just for this demo. Create bucket. AW. Okay, just giving some name. let me say business elite demo, for example. So let's say this is a business data set, right? I will just create this. Let me just take this table name, sorry, bucket name. I am creating this bucket. Let me go to the notebook. So this is my bucket name, guys, right? Business layer elite demo. There, let me create the new folder. Output. Let me create a bucket. Sorry, create a folder. So here I am having another folder with the name output. Let me copy that name. Let me move to the notebook. Okay. Let me recue this notebook. Now, guys, whatever the data frame you are seeing over here, I wanted to load into this S3 bucket. Connection type is of course S3. Update behavior update in database, that is in S3. I wanted to update the data. For now, I'm not interested in giving partition key, but you can partition your data with the help of, let's say, customer ID or sales ID, whatever, right? That you can ignore. And compression type, I wanted to say, let's say snappy compression. I wanted to give, it's a splittable compression, guys. Whenever you are storing data with the help of Parquet, you are compressing your data. But when you are compressing, you want that compression should be splittable, right? So for that purpose, you are giving the snappy compression techniques. And then enable data catalog to, these are some extra information that, okay, do you want to update data catalog and transformation context? These are just another few examples, things that you need to provide transformation context and all, right? In this case, transformation context is S3 output. Okay, now guys, I got this S3 output and I wanted to set format is a glue parquet, right? It, see, S3 AWS basically it's not parquet, direct parquet, it's a glue parquet, it's a wrapper over the parquet format, right? So that's why you see you are setting S3 set format is a glue parquet format, and then output data frame is like this one, right? Whatever the output you got in this session, right? This is pure SpicePark thing. You convert it into the this format, dynamic frame, and that dynamic frame you are now writing to the S3 bucket in this specific section. Let me run it, guys. So if you succeed, guys, we should see the transform data into your business layer. Okay, it you one return type that show that okay it succeeded. Okay, let me go to the business layer output. You see the Parquet file, right? Now, guys, this Parquet file, if you wanted to read, it's the same thing I showed you in earlier today's session only, right? You can create the, you can run a crawler on this particular, basically S3 bucket and run the query on top of the table that crawler creates, right? So that will not repeat now, but this is how, guys, you be using notebook option to process your data. So if I explain you things dynamically, sorry, diagrammatically, what's happening over here? See, we, okay, it's all, let me just duplicate these things. So what is different between earlier case and now case? See, I uploaded some file into S3 bucket. I use AWS Guru crawler to create the catalog. That still is still valid, right? I create some catalog over here. Then with the help of Athena, I also showed you how to query that catalog. But now with the help of Glue ETL, not visual, I apply entire enrich and business layer transformation into one place. Okay. So this I can delete just to show you, right? What I did here in, if I showed you my code, see, if you go to my code, what I did, I drop duplicate, right? And then I apply this transformation. These entire things I did over here, right? Drop duplicate, apply. So currently, see, in our case, simple example, I just apply business logic. Remove I apply the product with the amount greater than 100, but in your real world you will be using heavy transformation, right? Different transformation. So we'll dropping data, these things, drop duplicate with the help of notebook and apply business logic, and that data you load it into the business layer, right? What was the name of this business layer, guys? In our case, it's a business elite demo. So you loaded data into this layer. So guys, it's up to you how, if I generally prefer to run the things with the help of notebook, because simple thing you can do quickly, right? With the help of visual, sometimes it take time to create the complex thing, right? What it requires just to write few lines of code to drop duplicate and do some transformation. So I generally prefer notebook, but it's up to choice, people to people, right? The only difference is I just keep one layer in this second case, notebook case. But yeah, if I wanted to do, I can do even that one as well. I can do some transformation, sorry, remove duplicate, and that duplicate data I can put into the another S3 bucket. Then I can create another notebook. So the way here I create another visual notebook, I can create another PySpark based notebook which will read data from this enrich layer and then move things to another layer. So currently we did these things, but if you guys want, we can also do the same thing over here. Let me just revert these things. So I drop duplicate and I can load data into the enrich layer, right? Then again, with the help of, I can create another notebook. There in that glue notebook, I will apply some transformation and we'll move data into the business layer, right? So that's completely possible, guys. It's up to you that how you wanted to do. Just to save some time, I do all the transformation at a one place and move data into the this bucket, right? So that's what I wanted to show you guys. You can use glue ETL. Basically, glue it is a very good option if you wanted to apply transformation with the visual based things and the notebook based things, right? I generally prefer notebook based things. You just need to know the Spark for that, Spark programming, which I explained in earlier session, right? So then I think it's a comfortable. You can do you can build your logic based on your requirement, and you can, of course, you can write, let's say, notebook to read data from, let's say, raw layer, and after dropping, let's say, duplicate, removing NA sort of fields, and that NA data you can move over here. Then you get another notebook. Currently, you see, I just create one notebook, that is this one, analysis layer, right? But let's say there you can get another notebook, let's say business layer, for example, and that business layer notebook, then what it will do, it will read data from this enrich layer, right? And do some transformation and load data into the S3 bucket, another S3 bucket. And finally, with the public site, we can visualization team can generate some dashboard out of it. So this is how, guys, thing happen. Now, guys, this is what I just wanted to cover on AWS Glue. Another point I wanted to cover, right, with let's say DynamoDB as well, right? So the NoSQL part also I wanted to cover today, and let's combine that with the help of AWS Glue. Okay, so we will see that I will show you that how with the help of AWS Glue you can write your data into DynamoDB. So before going to that part, let me click on. Meanwhile, guys, if any question you have, you just please feel to interrupt me. Okay. So now, guys, we will focus on AWS, sorry, the NoSQL part. So we talk enough about AWS Glue. So now let's focus on AWS Glue part. Okay. Okay. Sorry, NoSQL part. Sorry. Guys, we till now we did some. If you guys remember, we mostly work on SQL database by now. I create the MS SQL, right, and other things in a few of the session. These were the SQL databases, right? But we also have the NoSQL databases, right? So what's the basically difference between them, right? In terms of data model, see, in SQL database, you have structure tables with the row and column, whereas in NoSQL, you have flexible model, right? Document-based databases, you have NoSQL databases, you have key value-based graph and columnar. These are different NoSQL databases you have. Schema is always predefined over here. It's a schema list, right? It generates a schema on the fly. Scalability, SQL is vertically scalable. You can increase the RAM of your SQL database to give more, to get more output. But in case of NoSQL, you have the option of horizontally scalable. So that's the main thing, guys, right? How much you cannot get to let's say 100 terabyte of RAM, right? There is a limit to scale things, right? But with the help of horizontal scaling, you can get more and more RAM based on your requirement, right? So that's the main uh, purpose of NoSQL databases. RDBMS definitely very good, right? If you want the complex joins and all, right, transaction based things, right, full ACID compliance, then we know, right, atomicity, consistency, isolation, durability. If you need these things, then of course SQL is very good choice. But with the NoSQL, you cannot write the complex join the way you guys we see, right? The PL SQL of thousands lines of code, right? That's something, and we are doing complex join. We are joining, let's say, 20 tables with left join, right join, whatever, right? So those you will not see those sort of query in NoSQL, not meant for that. The way SQL support ACID compliance, NoSQL support the base model. What is base model? It's a basically available data. So the moment, let's say, you put something on a NoSQL database, it it give you eventual consistency. It's not that okay, the moment, but let's say in a SQL database, the moment you do transaction, it should be available. Let's say I deduct some amount from one account and credit it to another account, it should be available on that moment itself. But that is not the goal of NoSQL. It's basically available data. Database should be always available, but data consistency is eventual. Maybe in one of the node you can see the data, but since it's a horizontally scalable, right, in one of the node maybe you might get some time to get that data. So it's eventual consistent, not it's like okay, I hit data and that the moment I click on, let's say, some submit button, I will get data. So that's it, not NoSQL made for. It support eventual consistency, not immediate consistency. Okay. And then soft state, right? What is in base model? We also have soft state, right? Due to lack of immediate consistency. So it's like, see, you NoSQL is not that immediately you will see some data, right? Your database will be available at any chance. There is no way or no 0%, 1% of chance your MongoDB or your DynamoDB is down. 0% of chance, right? It's definitely available. But consistency, you will not get the consistency the way you get in SQL database, because they are not meant for immediate consistency. They are meant for eventual consistency. Now, in terms of query, you can write a SQL query, whereas in NoSQL, there are multiple different query language, the JSON-based query, key value-based query, and those sort of things, right? Based for structured data, complex query, and financial system, right? Financial e-commerce, whatever, right? The moment, let's say, you want that complete control on transaction, right? And if anything happen, entire transaction get rolled back. So for those cases, SQL is very good choice. But unstructured data, semi-structured data, JSON data, logs data, right? Tweets, for example, just giving one example, right? So for those sort of things, if let's say you wanted to do some analysis on tweet data, right, or some IoT sensor, if let's say you miss few things, that's not business critical things, right? Twitter analysis, let's say sentimental analysis, is not a business critical things, right? If you uh, make some time to get some analysis, that's not business critical. But the financial operations, right, or other operations, right, in different organization, these are the critical operation. They want to be complete on that moment itself. So for these cases, you should use SQL based things. Example is like, guys, okay, sorry. Example is like, guys, in this case, uh, the MySQL, right? So this is all, I just noted that this PPT was not shared, but this is what I have covered, the entire thing: data model, schema, scalability, joins, right? I told about the it's not support the complex join and all things, right? It's basically SQL support, but NoSQL doesn't support it. Then we also talk about this ACID compliance. SQL is ACID compliance, but NoSQL is base model, right? It's basically available in soft state, right? And it's eventually consistent, not immediate consistent, right? Then a query language, right? It's about a SQL query, and basically it support you the SQL query, but whereas uh, uh, NoSQL databases support you the different query pattern, right? You can have JSON based query things and other things are also there, right? Uh, Let me remark, yeah. And then you have example like MySQL, Postgres, and other things, right? These are the SQL-based databases, whereas DynamoDB, Cassandra, and these are the MongoDB. These are the NoSQL databases. Performance is good for if you are writing complex query and transactions management. If you are looking into, then yes, NoSQL is a SQL is the best choice. But high throughput on a large data set. Let's say you are getting the billions of record in, let's say, 10 minutes. Okay, then SQL is not meant for that. Then in that cases, you should go for NoSQL databases. DynamoDB, MongoDB have history of handling billions of record in a few minutes, right? So that's what the performance it get. But of course, then it will not help you. It won't support you in eventual consistency. It will support you eventual consistency. It will not give you immediate consistency, right? Of course, there is some pro and cons when you are using right each databases. So you should choose right database based on your requirement. And we know, right? In RDBMS, if let's say you create a scheme table with, let's say, 10 record, you cannot insert statement with the 11 record, right? It's just less, it's not flexible, but it's a flexible, right? If let's say if I have uploaded one row with the 10 record, and then I can upload another insert another record with the 15 record, right? Third record with the 5 records. So that's completely flexible. So these are the some differences between SQL and NoSQL, guys. Now, in today's session, I will be explaining you DynamoDB. Let me go to the portal. Okay, let me click on sign in again. Okay. So guys, now I am in DynamoDB console. Okay. Let me create some DynamoDB table. Okay. Let me give it a name as a, and then I will also explain you that other things about DynamoDB while creating this table. Sample DynamoDB I'm giving you. I will use, guys, partition key. And so see, now since we are creating DynamoDB table, I wanted to show you which dataset I am trying to upload there. Okay, you see this dataset. This is one API, dummy JSON API. You can also query online. Okay, and it suppose huge data. If I just remove this limit parameter, it show you this sort of data, right? You see, I wanted to imagine that I have some upstream system which is giving this sort of data, and I wanted to, and it's giving this data, let's say, in every 5 to 10 minutes, right? Just for example, loading this currently for in our use case, I will be just copy it. For our use case, I will be just loading few records, but you see, loading these much of records, and that too, I just need some specific record from this, right? It's highly means, and imagine that either in real life, you can have the such system which are generating the millions of row in every 5 minutes. Then in these cases, your SQL database won't be enough, right? So you should go with, let's say, NoSQL database, and I will be using DynamoDB in this case. So what I'll be doing, I will loading some only few tables, a few records from here, like product ID, name, price, rating, discount, and stock, right? You see rating, all this information I will just load. Okay. Now let me just copy this thing, guys, and let me go to DynamoDB. So the partition key in this case, I will be using my product ID. So I will explain what is the concept behind the partition key. And Guys, if someone is not talking, please be on mute.
ಯಾನಲ್ಲ ಬರೇ ಬದ್ನಿಕಾಯಿ ಪಲ್ಯ ಪಾನಿ ಹೊಡಕ್ಕೆ ಆಯ್ತು ಈಗ ಅಂದ್ರೂ ಇನ್ನು 2-3 ತಾಸು ಇರ್ತದೆ ನೋಡು.
Yeah. Sorry, guys. Now let me reshare once again. Yep. So guys, what I will do in my this particular from this particular data frame, I will use partition key is the product ID, and let's say name I will be using as a sort key. Product ID and sort key. What is guys partition key and sort key in DynamoDB? Let me explain that via these things. Okay. So in DynamoDB, guys, you have the partition key and sort key. Partition key, basically, these are the unique things, right? Partition key and sort key make the key for your DynamoDB. DynamoDB is key value based things, right? So when you give the partition key and sort key, it forms the key out of your partition key and sort key, right? Partition key is a unique key, let's say user ID, product ID, right? And sort key is another key which can use with the combination of user ID. For example, let's say customer ID is your partition key and order date is your sort key. One customer ID can order multiple thing on multiple date, right? So this is how the combination of both you can use as a partition key and sort key, right? So there is also concept of global GS and global table. I will explain that when it would come. Okay. So now let me go to the AWS console once again. So I create the product and name. Why I create a product and name? Because in my response, you see, I have a second. Sorry, product ID and name. So this ID I'm considering it as product ID and name. That basically, if you see, I will show you how I'm getting the name, the title I am getting as a name. So these are the two key I am taking as a unique for just for this example. Okay, but it's up to you how you wanted to combine your product primary, basically partition key and secondary key. So sort key, sorry. So guys, now let me go to this console once again, DynamoDB, right? I create the partition key with the help of product key and name. Both are type of string, and let me create this DynamoDB table, right? This is how simple just to create a DynamoDB table. This table would be available in few seconds, right? This table is active now, guys. Now let me click on this table. I will explain you a couple of things related to that before doing one of the glue based operation that I wanted to show you. Okay. Yeah. So guys, see, let's talk about few more thing on NoSQL, right? Currently, in our case, we are just talking about NoSQL of type key value, but there are other NoSQL, right? NoSQL type, right? Document based. Let's say your MongoDB, it support a JSON-like schema, right? And it have their own pro and cons. It's a flexible in term of schema, right? For hierarchical data, it's a good, right? But the joins may if you need a complex join, then it doesn't support that, right? Key value, DynamoDB is our key value, whatever we are seeing, right? It store data into the in the form of key value, reduces to the key value databases. If you need a fast lookup, there is a key and give me the value, right? How we form the key with the help of partition key and sort key, that is the key. And then entire data set is another value. So that partition key and sort key is the key. Based on a key, you need entire data set. So if you need ultra fast lookup, DynamoDB is a thing, right? Of course, in NoSQL, you will be always having limited query capability compared to the SQL one. And then there are another NoSQL type like column family, right? Apache Cassandra, Edge based, they store data in the form of column, right? Instead of row. In upcoming section, maybe I will show you, right? See, when you are storing data in the form of column, you will get more better output if you are doing OLAP transaction, analytical transaction. Let's say you want some or average of, let's say, particular column, right? So in that cases, column family databases is more helpful. Okay. So these are some column family databases like Cassandra and all, and then graph databases. Graph databases, guys, useful when, let's say, there is a relationship between entities, right? Uh, let's say Neo4j, Amazon Neptune, these are graph-based databases, right? And let's say if you wanted to connect one data set to another data set, right? Let's say LinkedIn first connection in LinkedIn, right? You are connecting to some person, and right, and then it show you that okay, you are the person that you are connected to, they also connected to some other person, and you might know that. So that sort of data things, right? It's a graph based databases, right? So these are the other databases, NoSQL databases we have, but we'll be focusing on more on our key value based DynamoDB. Okay, let me move to the next slide. So what is key value, right? It's a partition key and sort key, I told you, right? They form your primary key, and all other data, right? It is acting as the other attribute. In key value, you will store your you will form your primary key with the partition key and sort key, right? And you can query only on this data. You cannot query, okay, give me the column, this, let's say this value or this value. You can only query on this column. But let's say if you wanted to query on another column, right? How we should do? Okay, let me go first these things. Then in this case, guys, you should use GSI, Global Secondary Index. It's another query pattern. Let's say, let me see if I have these things. Let me show you this GSI. Let's say you have this data set, right? Customer ID, order ID, country, and state. And you form the primary key with the help of partition key, customer ID, and sort key is order date, right? And of course, you will get all the data with the help of these two. If you just do, let's say, query get all order from customer C001, right? Because it's in your primary key, right? But challenge is if you want to get all order placed in Texas, you can query only on these two. You cannot query on state or anywhere, right? So DynamoDB does not allow you query on non-key attribute directly. Okay, directly, unless those attributes are a part of primary key, right? So attribute which are only are part of primary key, in this case, these two, only those you can query, you cannot query on another things. So what is the solution? Then you need to create a global secondary index. What is it? While creating global secondary index, guys, you just need to give the name of index and let's say give the another partition. So it's in a in your same table, you are creating the another index. You guys must be know the concept behind the indexes and all, index and all, right? So here you are creating another index on a state column. You can, and now with the help of this index, now you can query these things. Get all order, sorry, get all order placed in Texas. Why you can do that now? Because you create an index on this global secondary index on this key, states key. Imagine, guys, if in my DynamoDB table I have 100 columns and I want, but I can query only on this two column, right? For example, two column which are part of a partition key and sort key, right? But what if I wanted to query on multiple column? Yes, I can do that. Only thing that I just need to create the global secondary index on those column. Let's say state in this case, how much GSI you can get a 20 global secondary index, right? This is soft limit. You can increase by asking, raising some request to the Amazon. So this is a, oh, guys, GSI. I just wanted to talk you now. few more things, right? DynamoDB, I told you, right? It's a serverless. Let me talk few things about DynamoDB. It's a serverless provisioning, right? You see, within a few seconds, I create a DynamoDB table. No, everything taken care by Amazon itself. Automatically scale. It scale based on your load. The amount of load it get, it 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 help you to get that basically to cope up with that load, right? And if your load goes down, it automatically reduce the compute capacity of your cluster. So it help you in automatically scaling. Zero downtime. It doesn't have any zero downtime. On demand pricing. The based on your usage, you will need to pay for it, and idle for cost saving, right? If you don't have any activity, no cost. If you the moment you do activity, then only you need to pay cost for it. DynamoDB, you have different capacity model, on demand and basically capacity modes. Basically, these mode types are on demand mode and provision mode. What is these guys? On demand is nothing but the scale based on your request. The moment let's say you got more requests, it would scale automatically. Mostly people would prefer that because we never know how much data or how much volume that we need to request through, right? Most of the time. But if you know that this is much volume I need on a daily basis or on a if you know that things, then you can go to provision. It help you to define how much read capacity you need and write capacity you need you wanted to specify, and based on that only it support. But now in this case, if let's say you give the write capacity unit of some number and read capacity of unit of some number, but if you get more request, right, then your DynamoDB will not handle it. So better always, it's better to go on demand mode. Based on your request, it automatically goes up, and if request goes down, it will reduce your RCU or WCU, whatever, right? So these are different mode. And another important thing, guys, in DynamoDB, there is a global table. Let's say you create one dynamic DB table, right? And you wanted to move that table to be available across all the region. So let's say if one region gets down, that's highly impossible. But still your DynamoDB or even in some cases, right? Global table is like, let's say if my table is in India and my application is, of course, because I will be get a request routed via the table which is available in India region. But let's say if your table is in Australia, right? Let's say your application is in Australia and it's also trying to get the data from the India region. Of course, it will have some network lag, right? So global table help us to replicate this table across all the region so that it would serve from the nearest table which is available in that location. And it basically basically replicate data across all the regions so that each table in each region will have the same data. So these are the few things about the global table I just wanted to talk, right? This is a global table concept. And yeah, I think, yeah, okay. DAX, see guys, DynamoDB also support you DAX, right? What it do, it's a fully managed thing. So when you are querying DynamoDB, now I will be showing you one thing, how you need to write data into DynamoDB. But let's say you write some data into DynamoDB, right? And next time you wanted to read with the help of DAX, it will not go to the DynamoDB. It will just read from the cache. So the way it works, your app will write that data into the DynamoDB, let's say first time. Now let's say you want to read that data with the help of primary key. The moment you read that data, it will load that read data into the cache. Now, if I again query, let's say that the same data in some time, it will first of all look into the cache if that data is available. If it is available, it would serve from there itself. If not there, then it will go to the DynamoDB table, right? Update the cache and return you back. So that if you next time ask for same data, it will return you from the cache itself. So that's another one of the things, cool things that in DynamoDB we have. So now guys, let me go to DynamoDB tables. Our table got created, right? This is all the things that I told you, right? I just first explained in PPT. So in DynamoDB table, you have the indexes. Currently, I had not created a global secondary index, but you can create based on some the things that I explained you, right? On other key, which you might think that you need to query. For those, you need to create a GSI. Monitor is right. Just guys, how you wanted to monitor your data set. Basically, DynamoDB table, right? It's a monitor tab. all the logging and all DynamoDB table will do into the CloudWatch. CloudWatch is another service wherein all the services from your AWS will put log into your CloudWatch, right? And global table, I explain you, right? Currently, I not create any replica, but you can create the multiple replica so that from the closest region, it would serve that traffic, right? And then it would also support the backup, right? You can create the backup point in time. Let's say I want data to be backed. A second, let me see. Yeah, sorry. I repeat this point, guys. Move to the AWS console, but not share this part. Right. This dynamic DB, the setting part I just talk about. We create the partition key and sort key. Then we create, and this is a capacity model, right? I explain you in PPT. There is on demand and provision capacity mode, right? In our case, we use on demand only. And then indexes, guys, the GSI, right? Global secondary indexes. We can create the global secondary indexes from your DynamoDB, right? If let's say I told you, right, if because you can create only based on a primary key, but if you wanted to create a query on another key, then in that another ID, let's say, in our case, I think it was state column, right? Then in that case, it's not possible. So you should create the GSI for that, global secondary indexes. Monitor is one of the solution that just to monitor your DynamoDB table, right? In terms of logging and all, right? If you wanted to see that data, because all the services from AWS will move data, move logs into the CloudWatch log. That's also DynamoDB table also do. It will move its log to the CloudWatch, and you can see the metrics that how much percent of reads happening, how much percent of read is happening, right? Read throttle and all these things basically write input, basically write and read statistic you can see via CloudWatch metrics. Global table, I explain you that if you wanted to serve the traffic from the nearest one, then you can create a replica, and then traffic would get served from the nearest DynamoDB table. Backup, it support the point in time recovery for your data, right? If you want to, you should, if you are sensitive data, you should always take the, you can click on create backup and take the backup of your entire DynamoDB. Export and all these things, right? You can export your entire DynamoDB into the S3 bucket, right? That's also option is there, and permission, of course, who wanted to use and all the other thing. So now, guys, I have DynamoDB table ready. What I will do now, will I will go to the notebook, okay, and let me, in the same notebook, what I will do, write data in. So in the same notebook, glue notebook, we'll be writing some data into the DynamoDB, right? So let me explain you this thing, guys, quickly. First of all, I will need some these things, import statement, okay? These are the import statement I use. These are the request library, Spark context. Of course, if I need to work on a Spark programming, I need a Spark programming, right? Sorry, Spark context. Then glue context, I told you, glue doesn't know direct Spark. It works with the help of glue context, right? And dynamic frame is nothing but the on top of your Spark data frame, they build a dynamic data frame. Glue understand dynamic data frame. It doesn't understand Spark data frame, right? So these are the things that I have imported. Now, step 2, guys. What I'm doing, I am writing this piece of, just putting this piece of code. This URL is the same URL I have showed you, right? If I just copy this URL and paste it over here, it should give me all the 4 JSON data, right? Basically entire 4 record from this, because I apply the limit as the 4, this entire JSON data it will give me. Now from the data set, what I need, I just need, first of all, this on this URL, I am doing request.get URL, getting the response. From the response, I am just taking the product array. Okay, so this is my, you see, this is the product array I have, right? This is the array symbol. From the product array, I just need few things, right? ID, title, right? Let's see what are all this. I'm getting ID, title, price, rating, discount percentage, and stock. All these things are available over here. Discount percentage and stock, right? And then I map them as a different name, product ID and name, right? So let's say product ID, ID and mapped as a product ID, title I mapped as a name. And if you remember, on a DynamoDB table, we create the primary key out of these two column, right? A partition key basically, right? Partition key and sort key. So first was the partition key we defined, and second was the sort key we defined. So I got, so since I'm just getting the 4 record for each record that I'm getting, right? So in data, I'm getting the 4 record. I am applying for loop, and in each record, I'm doing, I create first of all one record array, and in each loop, I am appending this data into my record array, right? Now, let me do next step, guys. Now, guys, once I got these records, I'm creating the Spark data frame out of it, because to work with PySpark, first of all, I need to create a Spark data frame, right? But we know that Spark, let's see. Okay. So in this case, though I create data frame, I don't want it to do any filter or anything in this case. If I wanted to do, I can then do some transformation over here. But in this case, I just wanted to load the data that I'm getting from the JSON, sorry, API as it is into the DynamoDB. So on this DF, we can apply further. But in this case, I just wanted to load as it is, right? So for that purpose, I have created data frame. You can apply transformation, whatever you want. But after doing all transformation, I told you, you need to convert it into the dynamic frame, because Glue understand only dynamic frame. It doesn't understand your Spark data frame. Okay. So what you did, you pass this DF. Okay. Whatever DF you got, Glue context you pass. To convert a dynamic frame, you need to call dynamic frame.df method, and you need to pass your data frame Glue context and just the name over here, right? And then you will be getting data frame with the Glue context. Okay, because Spark understand only this data frame, not PySpark data frame. Now, guys, what I will do, I will write this data into the final piece of code. I will write to load data into DynamoDB. What I'm doing over here, see, I am using Glue context once again. Write dynamic frame from option method I am calling, right? What is the name of the data frame? It's a DYF, right? This data frame I have used. Connection type is a DynamoDB. Connection option. This is my table name, right? Whatever the DynamoDB table I have created, it's with the name of sample DynamoDB, right? And write percentage 1.0. What is the meaning of it, guys? 1.0 means Glue will use 100% of your write capacity, right? So you can specify that how much range you want it to do. Let's say you do, there are multiple options over here. Let me just, so you see, you can, the value range from 0.1 to 1.5. So how much percentage of write capacity you want it to use, right? That's what it helps. What happened? Yeah. Okay. That's what it helps, guys, to you to write into. Okay, Spark. Okay, 1 second. I think it did something. Let me just remove this piece of code. Step 5 we created, guys. I explain you that we create the step 5, and then finally let's do the step 6. Right, right, guys. So I explain you, right. You will be converting your Spark data frame into DYF, the dynamic frame, and this dynamic frame then you will be writing to the DynamoDB with this capacity. 1.0 means you are using the 100% write capacity of your DynamoDB, but its value is configurable. You can use more, and based on your usage, it would help you to use full capacity of your DynamoDB. Now, guys, let's run this piece of code. Let's see if everything is right over here. Let me run this. So this asterisk means it's in running set. Let's see if it succeed or it get any error. If it succeeds, guide, you should see some data into the DynamoDB. So see, I got one return type like this, which indicate it uploaded data into the DynamoDB. Let me go to the DynamoDB, right? Explore table item. Do you see, guys? All the data ID one, because I asked just 4 record, right? 1, 2, 3, 4. All data I have uploaded over here, right? So imagine, guys, the cases wherein you have this upstream system, right? This upstream system can push millions of record, let's say, to your source system. Let's say in 5 minutes, I am getting the millions of record, right? Normal databases won't be able to handle that. And that too, let's say in terms of some complex schema, right? JSON or another thing, right? So for that purpose, what we can do, you can use AWS solution like AWS Glue, right? For example, underlying it's a Spark only, but here what you can do, you can use the solution like AWS Glue. What this Glue would do, it would read data from this upstream system. Let's say here we have this API, right? But that API, let's say it's giving the millions of record. What your Glue can do, it can continuously run on every 1 hour, okay? Get, let's say, millions of row and put that record into DynamoDB table, right? So this is how, guys, you generally see that how with the help of AWS Glue and other solution, right? Data and engineering solution, you can upload data from this upstream system, do some transformation. Currently, we not did any transformation and upload data into DynamoDB. So you see now in our DynamoDB, I just loaded the 4 record, but at a one, let's say if you are running after every 5 minutes or any such duration, right? You can load the millions of row in every 5 minutes over here. And of course, then your another downstream system will use this data set, okay, this DynamoDB for this is upstream system. There will be some, of course, downstream system which will use this data for further transformation. So this is how, guys, you will use this millions of record. Maybe there is, let's say, another system which will read data from DynamoDB, do further transformation, and possibly it can load to, let's say, S3 bucket, for example, right? Let's say it will load into the S3 database, S3 bucket, right? So this is how, guys, generally people do activity in data engineering on day-to-day basis, right? You have the pipeline like this. You are reading data from the API or any third-party provider. Your downstream system may be in, let's say, Spark. It can be, of course, it could be a Glue or anywhere, anything, right? So this Glue can process that data, right? AWS Glue, and then that process data, then it would write to S3. And once you write data into the S3, then with the help of Athena or QuickSight, then again you can do visualization on top of data. So this is how, guys, generally you would see the data, the things happen in data engineering, right? So that's all I wanted to cover, guys, on a DynamoDB. You see that how quickly that we could connect to some external sources, and we can create some data by looking to this by running just some glue job, right? I told you, right, DAX, right? One of the solution. Yeah, whatever I was explaining in PPT. Currently, I am not creating any DAX cluster, but it's like, let's say the same thing over here, right? Whatever I was explaining. So let's say you write data into DynamoDB, right? And your downstream system will read data from the DynamoDB, right? But let's say while reading, if I just add DAX over here, let me see. I think it's a DynamoDB DAX solution only. One second, let me label it as a DAX. Okay. So this DAX solution, guys, what it do, it will, let's say it first read data from DynamoDB, right? But next time when downstream system wanted to read DynamoDB, it will not directly read from DynamoDB. First, it will check if data is available in cache. If data is available in DX, DynamoDB cache, then that data would get returned. But if that data is not available here, then what downstream system do? Downstream system call DynamoDB. It called DynamoDB. Okay. After calling DynamoDB, it then again update that data with the help of, it will again update data into the, let's say, cache, right? So that it will update that, it will call DynamoDB, right? And it will update that data into the DX, right? So that next time it will not directly query DynamoDB, it will query the DAX and respond back from DAX only. So that's what the one of the things in DAX, guys, just wanted to show you in DynamoDB. So these are all the points that I wanted to cover, guys, today. And of course, see, once you have data over here, if you just go to the table, right, and just if, let's say, if you currently I'm running entire thing, if I just all attribute DynamoDB, there are filters and all these things, you can just play with it. But in real use case, these are nothing but the filter to run, let's say, if you wanted to get some only specific ID and all. But in real world, you will be not running the query like this in your DynamoDB table. You'll be working, you'll be getting these huge millions of record via some Spark or any other library, right, and process that data. So just to show you guys. So this is one of the, guys, NoSQL databases I wanted to cover along with the glue. So that's what we cover today. In upcoming session, guys, we will focus on other things, right? Like we need to cover Kafka and other part as well. So we'll see you guys in the upcoming session as well. Any question for me, guys? Okay. If no question, guys, we can conclude today's session. We'll see you in upcoming session. Thank you very much.